Hello group, Jeff here. So I have a lot going on in the dungeon today, and one of them is, if I could get the camera to focus, it's right there. Right there, I am making a dew shield for my Newtonian. And the reason why I'm making the dew shield out of some extruded plastic is what I want to show you right now. I used to use a soft dew shield that kind of came as a flat piece, and then you would attach it and it would connect via Velcro to form the circle, and then you'd slide that over the end of the tube. And I need to support just a little more weight, and I'll show you why. The project is from and I apologize in advance if I mess this up, Scott Sudhoff. And if we go to the Mallincam Files section, he has put in a PDF on how he made a light panel, a flat panel, LED flat panel. And why this is important is it's a neat little project. Doesn't cost a lot of money, and if you're into making things, it's very easy to do. I kind of put my own twist on it because I couldn't get the exact same panel. I don't think they make them anymore in that particular model. China makes all the LEDs in the world, and as with anything in life, we're kind of at their whim, and it changes very fast. The LED market is something that changes in months, not years. So let's go to the, I'm going to switch to the desktop now, and we're going to go to the Mallincam group, files section. We're going to click on the uploads a couple times. That will change the order so that the newest is on top. And right here, LED Flat Panel Maker by Scott Sudhoff. And again, I apologize if I messed up your last name. We click on it. Scott did this in March of 2017, so it's almost 2 years old. And this light panel right here, I could not find. And if we look at it, his panel appears to be a Edgelit panel. And at the time I bought my panel, there were no Edgelit panels. There was only backlit panels, and I will show you the difference between the two. But if you go through what he's got here, it all works very well, and I put my little twist on it, and I will show you that now. Well, before we do that, let me just show you. If you type in LED 2x2, oops, sorry, flat panel, and you'll get a bunch of stuff here. I should have said Edgelit flat panel, sorry. There we go. And this changes things a little bit. Now, when I ordered my panel is a 48, what is it here, Jeff? My panel is a 40 watt, 5,000 Kelvin, and it's dimmable. And the dimmable part is important. And let's just see if we can find, yes, this looks like, so this is a flat panel edgelit. And the reason why I say that is it's very thin. And what an edgelit panel does is illuminate from the sides in towards the center. And the surface, the diffuser, has different layers of diffusion which carries the light towards the center. So you have even, the light is evenly dispersed from edge to edge, from the edge inward, I should say. With the panel that I have, a backlit panel, and let's see if I can find a backlit panel here for you. And of course, they don't have any more pictures. Let's see what we got here. Yeah, this is it. This is the panel that I have. And you can see that it's deeper. And the reason why it's deeper is the LEDs run along the back, right along here. And then the diffusion happens on this area here. So what can happen is you can get some dark strips along the gaps between the LEDs. Now that isn't a problem because you can put more diffusion in to spread that light out. And I'm going to do that is use a t-shirt, double thickness t-shirt, and I'll put that over my 14 and any other scope that I have, and that will take my backlit panel and disperse the light much more evenly, so that I can get good flats. So what I want to show you now is, we'll close this down, go back to here, go back to here, excuse me, is the panel. And you can see that it's fairly large. It's 2 by 2. I'll just step back a little bit here. 2 foot by 2 foot. There's the thickness, and where the frame is would be the total thickness of an Edgelit panel. And then the LEDs are along both this side and then this side. And then when you turn on the light goes in from the outside to the centers. Mine, the LEDs are along these depressions here. And I can get, if the power is low enough, I can actually see dark strips. So I would have a dark strip here, here, here. Now, as I said, I can use more diffusion, which will spread that light out. How I'll do that is use the t-shirt. What I want to show you now is my electronics. And I made all of this, and this is where I've changed it up. What Scott was doing. So I 3D printed a box to hold the 4 LiMo batteries. These are 600 milliamps each. That gives me 2400 milliamps, which is about 2.4 volts, or amps, I'm sorry. And then I have a switch right here that I got at Home Depot. And it's a wired switch, not a normal switch. And the reason I went with wired is it's one less connector I had to mess with. And then I have right here, I have a little buck converter. And the reason why I went with the buck converter is this is a dimmable panel. And because it's dimmable, I needed a means of controlling the voltage from the batteries. So if I turn on the uh, the, the switch, you'll see that I'm outputting to the LED 31.5 volts. If I hit the switch, the input is almost 33 volts. And I will never get the full 36 volts out of this setup just because I'm losing. I'm running these batteries in series. And because I'm doing that and the wires are so small on the clips, each clip, I'm losing a little through that, and I'm also losing a little in the buck. So if I switch back to my output, how I would change that is, let's see if I can show this. Whoop, get my finger straight. Right there is an impedance switch, or not a switch, but a screw. So by turning the screw, I can change the voltage. So I will try this. I'm doing it with one hand. And I've gone from 5 to 6. So let me see how far up I can get. I should be able to go to 32.9, I think. Okay, so that's, right now, the batteries have been sitting in here for about a month, so they're not the freshest batteries in the world, but I'm getting 32.6 volts, and you can see by my face, this thing's putting out some light. It's a 40 watt. Oh, I'm going the wrong way. Oh. Let me go back the other way. Sorry for the dead air. I gotta see what I'm doing here. That's better. There we go. So I'll put it back at 31.5. And the reason I don't want to go much higher than this is that gives me some overhead on with fully charged batteries. If I leave the switch on for by accident for like a half hour, I'll still have some headroom left in my power bank because when the batteries are fully charged, I think I'm at maybe a little 33 or 33.5 volts max. And right now I'm probably at 32.8. And because I'm drawing only 31.5, I've got some headroom. And what that headroom allows is for a more consistent light. It's not going to go up or down as the voltage drops, the brightness I'm talking about. So with this light, and I want to stress that you have to be careful if you go with these. You might have to talk to the manufacturers. This diffuser is plastic. I wanted to go with, let me turn the light off here. There we go. I didn't want a glass plate because this is 2 feet by 2 feet, and that's a big piece of glass. That's a lot of weight. And because it's backlit, I have a little extra weight because of this housing where you wouldn't necessarily have that with Edgelit. So you want to be careful that you get a plastic lens and try to stay away from glass. The other thing is safety. If the thing falls off the scope, you've got glass all over the place because it will break. At least if this falls off the scope, it's not going to really do that much damage. It might break the light, who cares? But I don't have glass all over the place. So I want to thank Scott for throwing that up a couple years ago. I just found it. I was scanning the file section like I try to do, and somehow I missed it, and I got back to it. It's something that can be easily done. If you go through resellers, some resellers make you buy 2 panels. I didn't want to do that, so I found a reseller that would sell 1, and they cost a little bit more. But for me, that was worth it. I think I have $52 in the panel. I've got the clips and the buck converter were $10. The batteries were 23, and the charger for the batteries was maybe $10. It wasn't that much, and it uses 5 volts to charge these, so it's not like it's a big expense. And because these are LIMO, there's no weight in this at all. I mean, you don't even know it's there. And I just have this attached to the back of the LED using Gorilla Tape. And you just apply a little heat and you can pull it off. So if you have enough gumption and you feel like this is something you can do, go for it. You get yourself a, it's not something as cheap. I think I'm a little under 100 for this thing. I enjoy doing stuff like this, so I don't, you know, big deal, $100. I know you can buy panels, but because of my bigger scopes, I needed to get something that would cover that wide range, and I was having a hard time finding a 2x2. And this was the way to go for me. So I hope this inspires you to figure out how to make your own LED flat panel. Flats really help. One of the reasons I decided to do something like this was I forget to make flats. By the time I get around to and remember, oh geez, I didn't make flats, it's already too dark to make them. So it won't matter anymore. If I forget to make my flats and it's dark out, I can use this LED flat panel, and that will solve my problem. And it takes for one scope, it takes maybe a minute to make flats. It's not a big deal. So hope you enjoyed this, and we'll see you in the group. Talk to you later.